Okay, so in the first problem of our homework 6, we're given a probability density, a joint probability density function of random variable x and y. It's like this. It's a non-zero area. It's a square, and we have 5 problems to deal with. So let's take a look at the first. We need to find out what the coefficient is in order that is it a valid density function. Well, we just do the integral of this joint density function, and we got the final result for a. And if such joint density function is valid, then for a must be equal to 1. So we get a equals to 1 over 4. The second question, we like to know whether x, y are uncorrelated or not. Well, remember one way to judge whether x, y are correlated or not it's to examine whether the product of their expectation equals their expectation of their product. So that's whether this one holds exy, whether it equals to ex multiplied by ey, and we could calculate ex. It's like x. This is the definition. As for marginal function f(x), we could just integrate y, we just integrate y over minus 1 to 1, because on the other side, on the other parts of the real line, our density function, the joint density function is 0, and and we could just continue our calculation, and we could get that this equals to 1 over 1/2. So the second term just cancels itself. So if we substitute this f(x) with this with this number 1 over 2, we can find out that the function to be integrated is an odd function, while the interval is symmetric to the origin. So the integral is 0. And so the same thing applies to expectation of y. So we get expectation of y and expectation of x are both equal to 0. However, when we calculate the expectation of exy, we get the expectation of xy. We get according to the theorem, it should equal to xy and multiplied by their joint density function. It should like this, but this is obviously a non-zero number, because you can see the second term, this is an even function with respect to both x and y. So the left side is non-zero while the right side is 0. So this doesn't hold. So xy it's not uncorrelated.